So where were we? Degree of flocculation. In both situations, if f equals to f alpha, then beta will be 1. This will be a theoretical minimum and serves a baseline. It provides some idea about the extent of flocculation. If the beta value is near to 1, then the suspension does not represent a flocculated suspension. It indicates that the system under study is a deflocculated system. But beta can assumed by any value greater than 1. In general, the higher the value of beta, the greater the physical stability. Please note these things. In general, the higher the value of beta, the greater be the physical stability. Okay. It is a destructive method of testing because the flocculated system is converted to a deflocculated by the addition of deflocculating agents such as electrolytes. The sedimentation volume of deflocculated system is less than that of flocculated system. The minimum value of beta is 1 when flocculated suspension sedimentation volume is equal to the sedimentation volume of deflocculated suspension. Now the interfacial properties of solids. A good pharmaceutical suspension should not exhibit the settling of suspended particles. An acceptable suspension should not exhibit settling of dispersed solids. This can be achieved by reducing the particle size to a level of 5 micrometer so that they exhibit Brownian motion. The sequence of events that follows the size reduction up to a stable suspension is depicted. Since the size reduction implies that work, which is represented by W, capital W, has to be done to divide the large particles to smaller particles. This process can be written as capital W equals to delta G equals to gamma SL multiply with delta capital A. Capital W equals to gamma G equals to delta G equals to gamma SL into delta A, where W represent as work or work done, delta G which increase in surface free energy, and gamma SL is the interfacial tension between the liquid medium and the solid particles, and delta A, capital A, increase in surface area of the interface due to size reduction. During size reduction, the surface area of the solids increases enormously, leading to an enhanced surface free energy, that is delta G, a state in which the system is thermodynamically unstable. Now, the system spontaneously reacts and tends to return to a stable state in order to reduce its surface free energy, delta G equals to 0. Two approaches are possible to regain the stability. In equation, the delta A may be reduced to 0 so that delta G will become 0. Okay, this is possible by regrouping the particles to form aggregates or flocks. From the point of physical stability, such a change is undesirable. The pharmacist should strike a balance between the particle size and stability of the system. Okay, regrouping of particles with strong interaction can be prevented by paying attention to the following points. 1. charge on the insoluble solid surfaces, and the formation of electrical double layer. So regrouping of particles with strong interaction can be prevented by paying attention to the following points like charge on the insoluble solid surface and the formation of electrical double layer. Number 2, zeta potential of solid surface, which can be done by adding the electrolytes. Zeta potential of solid surfaces. And next one is particle to particle distance and their influence on the potential energy barrier. In order to achieve stability, substances such as electrolytes and polymers are added. Dilute suspensions are relatively stable based on the interparticle distances. High viscosity restricts the movement of particles and prevents the aggregation and sedimentation. So the larger particles, if there, in case of a dispersion medium, that is a solid stable state in which the surface area is low. Larger the particle size, surface area is low, and surface free energy is also low. When size reduction is done, there is some work done is there. Spontaneous process is done. So surface area is large. That means when the big particle size are reduced to smaller particle size by size reduction and some work done is achieving there. Surface free energy is also high when the surface area is large or surface area is high. So big particle to small particle, surface area is high, surface free energy is also high. Small particles are generally unstable form or unstable state. So when structured vehicles is added to this small particles or unstable state, then hard cake is formed, and that system should be called deflocculated systems. And when the electrolytes, polymers, and surfactants or flocculating agents are added to the small particles or the unstable or the small particles of that unstable state, then light fluffy conglomerates is formed. That system should be called the flocculated systems. Thus, the following two approaches are used to retain the stability by reducing the delta A, or by reducing the interfacial tension. I have already told previously.